Okay, as you can tell, I pushed your quiz, your chapter test back one more day. I wanted to finish the review out, and I had some technical difficulties with recording and writing on Friday, so figured today's a good day to finish the review out for you and give you an opportunity to ask any more questions before the chapter test tomorrow. So get on the Google Meet if you have any questions. Let's go ahead and finish this review out. Sine of 7 pi over 6. Looks like I'm going to have to go back to the handy dandy unit circle. Oh, look, it's right there. 7 pi over 6. Sine gives me negative 1/2. Cosine of 3 pi over 4. Let's check to see if that's on the unit circle. It is. It's negative root 2 over 2. So those are the easy ones. I hope you guys get those ones right. Then we have tangent of 8 pi over 3. I'm going to check my unit circle first, although I know it's not on there. 5 pi over 3 is my biggest one. So now let's go back to 8 pi over 3. Let's think about what 2 pi is. 2 pi is a fraction over 3 is 6 pi over 3. Multiply the top and bottom by 3. Now subtract that 6 pi over 3 from the 8 pi over 3, which gives me 2 pi over 3. Take the tangent of that. Let's see what 2 pi over 3 is in my unit circle. That's root 3 over 2 and negative 1/2. So tangent is going to be root 3 over 2 over negative 1/2. Which means we flip and multiply. Root 3 over 2 times 2 over negative 1. Your 2's cancel. You're left with negative root 3. Lastly is sine of negative 7 pi over 4. Not going to find that on the unit circle. 2 pi over 4. 2 pi is equal to 8 pi over 4. Subtract the 7 pi over 4 from that, and that'll tell you how far we went on our unit circle. That's pi over 4. Sine of pi over 4 is root 2 over 2. And that's it. Let's move down to the next section. Express as a single real number, no decimal approximations allowed. So first I have to find the cosine of 3 pi over 4. Cosine of 3 pi over 4, as we found up here, is negative root 2 over 2. Now take the sine of 5 pi over 6. Sine of 5 pi over 6 is 1/2. So that's times 1/2 minus sine of 3 pi over 4, which is root 2 over 2. Times the cosine of 5 pi over 6, which is negative root 3 over 2. Well, this looks ugly. So if I multiply these, that gives me negative root 2 over 4. Multiply the tops, negative root 2 times 1, 2 times 2, minus, then it's root 2 times negative root 3. So that minus a negative is going to make it a plus, and that would be root 6, just multiplying what's inside the roots, over 4. Now, because I have negative root 2 plus root 6, those are not the same base inside of here, so we can't do anything else with them. That is our final answer. If I get anything except that for a final answer from you, like 0.77, who cares? It's wrong. Need to know how to work with those roots. Okay, sine of pi over 6. That is 1/2 plus 1 squared. 1/2 plus 1 is 1.5. 1.5 squared is 2.25. That's your final answer. But Russell, I thought you said we can't have decimal approximations. This is not an approximation. It is an actual value. So it's not a decimal approximation. Sine of pi over 2 is 1. Sine of 0 is 0. Cosine of 0 is 0. My final answer is 1. That was my favorite one out of all of these. Get it? Favorite one. Got them. In exercises 2 through 4, graph each function on the given interval. So I have sine of t on 7 pi over 2 to 7 pi. Oh. So the first thing I'm going to do is, well, here's the thing. If you guys are going to graph these for me, you're going to have to use Desmos. So here's how I would do these if I was you. I'd start by going to Desmos.com. It's a good start. I would then log in. You can see I'm logged in here. Graphing calculator. Now what do we have to graph? Sine of t. So let's do it. Sine of x. So I could put an interval in here. I think 7 pi over 2, comma 7 pi. Nope, didn't work. Let's try it this way. Do a comma. So we're going to do a comma, 7 pi over 2. Then less than, equal to. If you just push the less than, equal to on the keyboard, it makes it into the right sign. X less than, equal, 7 pi. Well, that still didn't work. Huh. I thought for sure that was going to work. I felt so confident. What if I put some squiggle brackets in? See if that makes a difference. Didn't work at all. What about a y equals? Still no luck. Well, this sucks. Y equals sine x. Guess that's as good as we get, huh? The other way you can do it is to do it manually. I guess that's what you're gonna have to do. You're gonna have to do it on a sheet of paper. Yeah, that's what I wanted you to do from the beginning. So the easiest way to do this on a sheet of paper is going to be to look at my unit circle and pull some values. If I have 7 pi over 2, that is my starting point. It's going to be out here somewhere. And if I look at my unit circle, let's see, 4 pi over 2 would be 2 pi. 8 pi over 2 would be a total of 4 pi. I'm just looking at 7 pi over 2. Okay, let's look at this a different way. This is 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So the sign of that starts at negative 1. So if I'm starting at a random 7 pi over 2, then my y is going to be at negative 1. Then just move on to the next one, which is 2 pi. And it's going to be at 0. Now we're just going up by 1 pi over 2 each time. So 2 pi is the same as 8 pi over 2. 9 pi over 2 is going to put us back up at 1. Ten pi over 2, or 5 pi, puts us back at 0. 11 pi over 2 puts us back at negative 1. And we just keep cycling through until we hit 14 pi over 2. Yeah, that's pretty, huh? And so I'm not going to give you one that's that long to graph, so that you have to keep cycling through it. In general, I'll give you one that's much shorter. Same thing here. This is a long one. Basically have to go back to cosine of negative 5 pi. The important part is finding that on your unit circle. So it's negative pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi is back at negative 1. So my y would be negative 1 at negative 5 pi. And then I'm just moving along. And then your tangent from 2 pi to 3 pi, when you graph this, this one looks different than the other two. Cosine cycles, sine cycles. For the tangent, if I think about at 2 pi, so 2 pi here, it's sine over cosine for the tangent, which is 0. So at 2 pi, call this 2 pi, I'm at 0. This should just be pi. At pi, it would also be at 0, because it's sine over cosine, 0 over negative 1. In between there, it's a 3 pi over 2. If I look at that one, that's going to be 1 over 0, which is undefined. So 3 pi over 2 is going down like this and up like this to the next one. 3 pi, we're back at 0 again. And we're kind of repeating this same process. We have asymptotes here and here. Even though I'm supposed to stop at 3 pi, which means that all of this would be gone. And this is all I would be looking at from 2 pi to 3 pi. Okay. I'm not going to kill you with those graphs. I'm not going to make it so hard that you can't graph them. A lot of them are going to be just knowing how they look on a regular standard cycle. Okay. Look at number 5. These ones are the more important type. for now. Make sure to throw that in there. So cosine of t equals 1. Where is t going to be equal to 1 at? If I'm looking at the cosine function, I start here at 1. So when x equals 0, that's my first time that it's at 1. At pi over 2, it's at 0. At pi, it's at -1. At 3 pi over 2, it's back to 0. And at 2 pi, it is back up to 1. So I kind of have this shape. Notice I said kind of have that shape. So if you remember for these, all we have to do is 0 plus 2k pi. Because at every 2 pi, it's going to be back up at 1. When is the sine of t equal to -1/2? If I look at my sine function, it starts at 0, then at pi over 2. Pi. At pi over 2, we're up to 1. Then we're back down to 0. Then at -1, then back up to 1. I'm sorry, back up to 0. You know what I meant. So we are going to hit 1/2 here and here. And that's going to be on a continuous cycle. So whatever our first value is, plus 2k pi. And whenever our second value is, plus 2k pi. Now, how can I find what my first value is, where it's -1/2? I just now saw the negative. So that's actually down here and here. Just go to your unit circle. When is the sine -1/2? My sine is -1/2 at 7 pi over 6 and 11 pi over 6. Seven pi over 6 and 11 pi over 6, and I'm done. Plus 2k pi for each of those, because it happens for every time we go through that period. Lastly, when is the tangent of t equal to -√3? Look at the unit circle. When is my sine -√3 over 2? Well, when is my sine √3 over 2 and my cosine negative? That would be here at 2 pi over 3. So it's negative here. If I look down at 2 pi over 3, it's not going to be negative here because that's a positive and a negative. But at 5 pi over 3, it would be as well. So it's going to be 2 pi over 3 plus pi, not 2k pi. It would just be k pi. And at 5 pi over 3 plus k pi. You can do plus or minus. The reason that it's just pi here is because our cycle for tangent only lasts one single pi rotation. So it's from here to here as opposed to going through a whole cycle at 2 pi. All right, guys, please come on to Google Meet if you need help. Chapter test is tomorrow and Wednesday. No pushbacks this time. We're finally there. And then we will start calculus shortly after.